Well, hello again, guys. Yeah, well, I thought we'll do another video on the Breville M97. Some people say M96. There's so many models, but anyway, I'm sticking with 97 because that's what matches my circuit diagram. Now, today we're going to check out this bit, the transformer, the audio output transformer, which is actually mounted on the speaker, the field coil on the speaker, and today let's have a look and test a couple of electrodes which I know will be faulty. They're being replaced anyway, but out of interest, replace them. And this resistor, this big resistor in here. Now, I don't know, that's probably 40 or 50 watts, I reckon, at the time. Doesn't actually say on my circuit, but yeah, I'd like to know whether that fella is okay, the taps are working okay. So let's start at the beginning here. I have the rectifier valve, which is it's an 80 on this one. He's unplugged. I do have the power cord cut off at the moment. What I'm going to do is put just a double cord on this, a 2-core cable on this for the moment. It's going to be running through the dim bulb and the isolation transformer. So we'll bring him up and see if we've got AC HT, and then after we check the caps to see if they'll withstand it, we'll put in the 80 and see if we've got any B+. That's as far as we'll go with this video. Don't want it a lengthy one, but we want to know, well, the next part of this is what else could be wrong with this. So let's start at the beginning, and I'll get this positioned up. I should make up a frame for this. I haven't done yet, but yeah, probably will make up a frame so that we can work on this a little bit easier. Let's start with the transformer. Right, now as you can see with this one, there is no on-off switch. So yeah, I don't know what to do about that. I don't know whether to put in a switch pot, but I don't want to put another pot in place of this one. I would rather the original. So I don't know. We might leave it as standard so that you turn it on and off at the power point, I think. This was how this one was. And, well, I'm guessing that's how it was. There's nowhere else for a switch. So we'll leave it at that. Now, here's our transformer. Now, we've got a few taps here. We'll just grab the circuit and I'll show you the schematic of this little bit here, the power supply, just so you know what we're dealing with. Fairly simple setup. AC up here. Now, it looks like we have 3 taps there. Probably it's not written on it, but probably 250, 240, maybe 220 for this one. We've got a 4-volt winding, which is actually for our AK2 heater. Here's a 4-volt tube. And 6, obviously, center tap 6, which is for the rest of the valves. And an 80 for the rectifier. So this is what we're checking at the moment. The main, transformer, primary winding. I'll also put a meter across here without power at the moment, just to see, you know, is this thing going to fire up or what's going to happen? Primary winding. Now, you guys are seeing this for the first time. I haven't actually had a look at this radio at all. I'm just getting my chair ready. Ready for disappointment, probably. And Good, we have 58 ohms. So it looks like our primary is fine. Now we've got a tap out here. Nope, that's not connected to anything. This fella is 49 ohms. So that would be probably 220 volts. Hang on a minute. It is marked. We've got, just a moment here, I'll just get another light. 260. And we've got 260, 240, 200, 200, and common. Now, strange thing about this, the 260 volt is either not connected or it's open circuit. It's interesting. The 240, which would be the one we're using, is 58 ohms. So primary's fine, which is a good thing. That is a really good thing. So we know the tranny's probably going to fire up on the primary. Secondary, we've got a common here, and we've got something that says, I can't read these, 385, 385. Now, I don't know whether you guys can see that or not. It's very hard to see, but 385, 385, and obviously centre tapped. Now, that centre tap, I think, is not grounded. Let me see. Yes, it is. The centre tap is grounded, so we don't have a bias setting. It actually goes up here to, yeah, it's not insulated. Chassis ground. So let's check the secondaries. Obviously without voltage just at the moment. This one, 369. Sounds normal. This fella, 399. A little bit of discrepancy there. 369, 399. So 30 ohms difference between the windings of the secondary. And that is these fellas. That one there, that winding there, and this winding up here. So 30 ohms difference, and as you can see, the centre tap goes down here straight to ground. There is no biasing for your tubes or anything in this radio. So yeah, a little bit of a worry with that, but the proof will be when we put some power on and see what happens. Now, obviously, that's the 5, the 6.3 volts. I'll try and get a better picture of this for you guys as we go along. A little bit of haphazard soldering in here, not real good. That sort of has nothing of consequence written on it. I'm sorry, this is our 6.3. And he's reading 0.4 of an ohm, which I would expect. And the red goes over here to the 80. Now, this would be your 5 volt winding for the 80. 0.4. Or is it 6 volts? I'm not really sure what an 80 uses. I'm not real sure about that. I will pause the video and go and have a look what the characteristics of the 80 are. But it has its own filament winding, a directly heated arrangement. So 3 comes out here, which is obviously your HT, which is on your filament winding, and 3 goes to pin 3 here. Then we go to pin 2, the field coil. Then we come back from the field coil to number 4. Number 4 here. Right, well, the first things first, the 80 rectifier. Filament voltage, 5 volts. So there we go. So that's a 5-volt winding. And it draws 2 amps. And the plate RMS is 350. So there's some of the specs on the 80. So yes, it is a 5-volt filament. Let's drag out the other circuit here. Right, now model 81 we've got now. Now an 81 actually uses an AK1, not an AK2. Slightly different in around this area, and in around here it is also slightly different with our settings, voltage settings on the resistor. What we can see here is comes out of the 80 through the field coil, goes to a couple of points here, goes to our control grid, comes down here, which is our HT line, and also goes to the speaker transformer, which goes up to the plate of the 42. So we've got to check this fella, and we've got to check this fella, and we know most of this is going fine. So we also have the 2 8 microfarads there that we have to check. The circuit diagram in this area is identical to this. So it's a mix of, well, really, a 97 and an 81. We've got to work between them. But neither is identical to this. But we're that close that it really doesn't matter. So, okay, so we're going to measure 2,000 ohms through the field coil, which is very handy to have there, but there's not many other voltages or ohms readings or anything anywhere. Okay, so X is your filament for your AK2 in our case, and Y is the other valve. So Y is 6.3, X is 4 volts. AK1, AK2 run on 4 volts filament. Right, we'll keep that circuit handy. So the next thing to check is, where are we up to, is the HT. We've done the HT, which comes down here. The red wires here are your 5-volt filament, which I think we've checked, which is 0.7, and the red to there is to the 80 filament. And that's about all we can check in this area to see whether this is going to work. We'll also put a meter across the caps to see if it's okay. Just while we're here, this resistor, it's a worry, this one. It's supposed to be 15k. That end, and yeah, we've got 2.2 meg. We've got a problem here. So up here, we've got first tap. First tap, probably 140k. Second tap is, yeah, she's open there somewhere. This could be just bad connections underneath the bracing there. Next one, let's go from here down to here. No, 2.2 meg. From here down to here, and we're measuring open as well, so I don't quite know what's going on here. 2.8k. We're right with this section. This section to the next, 1 meg. Jumping around all over the place. The easiest way to do this will be to remove the resistor, and we'll get him out on the bench and check him. Okay, let's throw the ESR on these and just see what it's like, to see will it withstand a bit of voltage coming in. The first cap, which is an 8 microfarad, if I can get him on there, down to here, and nothing. I'd say he's open circuit. So to start with, we'll probably put that cap in. Not going to fire it up with an open circuit cap. Okay, got this fella on, and 0.1. That's not real healthy, is it? 0.1. Let's try this one. 2 mic. Yeah. So the deal is, before we put any HT on this, before we put the valve in, the 80, and run up some HT, we'll change these two fellas here. And I don't think there's any other. There's one electrolytic up here, which is a very strange looking item, but anyway, we'll deal with that later. Okay, I think now, seeing we're on transformers, the next thing will be the field coil and the actual speaker transformer. Right, now, as you can see, we've got a little bit of work to do on this speaker. I don't quite know how this is going to go, but I think some probably use some coffee filter paper and some doping compound, and I think we can actually rebuild the cone. But anyway, we'll deal with that later. What we've got to deal with now is the speaker transformer, which is this fella here, which will be our red and, well, probably blue. I guess that's blue. Okay, we'll go across those. Now, we'll also have a look at our circuit. Now, this one doesn't show the plug, so we need this fella. So, number 1 is not connected. 2 and 3, there's a jumper wire across 2 and 3 there. So it's those two. 4 is your speaker transformer and your field coil. So it's that fella. So there's 2 cables go into there. And this fellow up here is the transformer. So that's our speaker transformer. And our field coil, we should have a reading between there and there. Okay, yeah, that's right. Field coil, speaker tranny. Let's see what we've got. And hopefully we've got some resistance. Okay. Now, just get my chair again. We'll put this fella on. He's the common one between them. Now, first of all, we'll do the speaker transformer. Oh, look at that. 606 ohms. Okay, now I'm assuming that is the speaker transformer, and because that's what the book tells me. And this one should be the field coil, and he'll be lower ohmage, I guess. If I can get him on there. 195. No, we're not. I wonder, is this the speaker plug back? Okay, we're measuring from the back of the plug on this. So this is the speaker transformer, this one, which is 1.9, say 2K, which on the other diagram, there we go, 2000 ohm. So we're spot on there, and this one is your field coil for 606 ohms. That's okay as well. It's a shame there's so much work to do on the speaker. So there we go. This transformer setup is going to work. Just got to fix that bit. It looks a bit daunting at the moment. You'll be right. We'll get there. Okay. So they're okay. Next job. I'll change the two caps. I'll do them now, and then I'll put some AC on our transformer and do some AC measurements. Now at the moment, for testing purposes, I'm just putting on a little terminal block. I'll just bring you guys in a little bit closer here. Reason being for the terminal block is it's easy to disconnect when I'm working on the rest of the unit, and I don't want anything permanently hanging out the back of the radio while we're trying to do this. This is only temporary until we see what's going on here. Now, if you're working on this gear, please take care. This is lethal voltages. Everything is, well, here at the moment, what I'm playing with is a mains potential. It will kill you if it gets hold of you, or a very, very nasty shock. So please take care when you're working on this. Don't necessarily do what I do. Do the right thing and stay alive. So far, I've been very lucky. All right, so there's our cable. Let's replace this capacitor. Now, once again, this is probably going to be tacked in place just to see if can we get HT out of this thing. We're not going any further. We know this is not working. Yeah, we'll just replace these. He's as hard as a rock. 8 mic, 525 peak volts. We're putting in little fellas, 500 volt, 8 mic. I'll just temporarily solder him on the pigtail. Once again, that's not good. Keep the sheath in case we need it somewhere. It's quite pliable, so can be used again. And the same with the other one. Right. Okay, so we're all set up. Negative to ground, it's correct. Positive and positive to there. So we're all set up to do some voltage checks. Now, the other thing that looks a bit sus is the 6.3 volts. I don't know what I'm going to do there. I don't want anything. Yeah, this is starting to come apart. I don't want anything too short. It may not. But I think this one they've used a Band-Aid to keep it apart. That's handy. Save me getting my Band-Aid. Okay, well I don't think there'll be anything. Oh, don't think there'll be anything shorting on that line, the red line, which is up here a bit. Is pretty ordinary. You can't see for my arm there, but I'm just separating them to make sure nothing's going to touch. I think we're ready to apply some power. We'll run the variac up. We'll be running this in dim bulb, of course. You certainly wouldn't chance it any other way. So I will plug everything in and come back. Right, guys, we're hooked up. Got 6 volts there. I haven't got anything turned on yet. So it's just, well, there's voltage going to the variac, but very little. Okay, let's see if this is going to come up. I'll just, okay, there we go. We're on 246 there. We should be looking at around 500 on the secondary of this fella. Now, we're on 100 volts on the variac. We're on 350 as we speak at the moment. Dim bulb is nothing's happening there at all. Not lit up. Okay, 400, 500. Seems pretty high. How many watts are we drawing there? We're drawing, well, nothing. 1.5 watts, which is normal. Let's measure H1 to ground, which is the center tap. A good ground point on this. Yeah, up here on this cap, I guess. Okay. Let's see how we go now. Okay. On 220. That's actually, what are we on there? We're on 230 volts. We're drawing 3 watts. And we're on 395 on that side, AC. And what's on this side? 395. So, yeah, we're looking very close to 800 volts across it. That's one side, 395. Other side, 395. So it's certainly well balanced. Okay, next step. Let's try the HT. Let's put in the 80. Or also, let's check filament. Across the 6-volt winding, we have, I hope you can see there, 6.63, 6.6. That's pretty good. Okay, the 5-volt winding, for the 80 is 5.2. And our other winding for our AK2 should be 4 volts. If I can get him on, 4.5. So, transformer, all looks good so far. And I didn't have my microphone on. So how about we put in an 80 and see what our HT is. It's not going to go anywhere. We've got our field coil unplugged, so it's only going to stop at the socket here. It's going no further up here because we don't want it up here. So let's put the 80 in, see what he measures. DC this time. Now I'll leave him on that angle, just bring you guys in a little bit closer, I think. Right, so we can see what's going on. Once again, meter to ground, positive to the 80 down here. Okay, so there you go. So this is it. Let's put things on and see if he's going to conduct. Now we're sitting on 90 volts. We're pulling 3.5 watts and up she goes. Boy, that 80 is working well. Okay, 90 volts. And we're sitting on 180. We'll take him up to 120 volts. There's your HT, 268. We'll take him up to 150 volts, 340. We'll take him up to 180, 400. This is, of course, no load on the HT. And we're drawing 8 watts there at the moment. 200 volts on 450. 230. 230. We're at right on smack on 500. Okay, so that 80 is certainly very good. Those caps haven't blown up yet. I'm waiting for one of them to go bang, but they must be quality caps. They're rated at 500, so we'll just back him off a little bit to 220 volts. There you go, 220. We're drawing 11 watts, and we're at 491. There we go. There's our HT. Very high at the moment because nothing is connected, and there'd be a pretty hefty load with the rest of the radio on this fella. There we go. So HT is working. We can turn him off, unplug, because we know all this works. And when you're doing this, don't touch those caps until they're discharged, or use a resistor yourself. Be very careful and discharge them before you touch any wiring of the caps, because it will give you a fairly nasty boot. Yeah, it'll turn you off radio. Alrighty, so we'll let this fella count down, and yeah, the next part of the video, we'll remove this fella. We've got to check out what that capacitor is up there, and then we start really up the top area of sort of restoring up the top, repainting, getting rid of the rust. I don't want to do a whole lot under here because there could be paint spatter and well, this will probably have to go in the sandblasting unit. So yeah, I don't want new components damaged in here. All right, he's coming down. So there you go. Part 2 of the Breville model, you make up your own mind, model 81. You think it's an 81, but we've got a problem here and in here. Or is it a 97 where everything matches? Okay, I'll let you make up your own mind. Okay, if you want to keep following this, please remember to subscribe, hit the bell, and you'll be notified as soon as I put the next video up. I hope you're enjoying this. This is great fun doing this, fella. Okay, until next time, bye for now.